This is a group of drugs that we use to treat ulcers. And we have different. Omeprazole is the cheapest, but we have others. We have omeprazole, pantoprazole, esomeprazole. We have a lot. We give this drug also 2 times a day, twice daily. So we give 3 drugs, hence the name triple. We give amoxicillin, clarithromycin, and omeprazole 2 times daily. But this is only one therapy. We have different. Anyway, the triple therapy, this is one of the treatments that you must remember, because Helicobacter pylori infection is the most common chronic bacterial infection in the world. And you must remember the treatment of this disease, okay? This is the triple therapy. And before we finish Helicobacter, we want to say some words about the diagnosis, because this is an important disease. So we can make the diagnosis of Helicobacter pylori by 2 different ways. We can make the diagnosis by taking a sample from the stomach, so taking a biopsy from the stomach. So this is the invasive way. So we have to enter in the stomach and we have to take a biopsy. In this sample, in this biopsy, we can look for Helicobacter pylori using microscopy, and we find it many times, or through culture in the laboratory, and we wait to grow Helicobacter pylori, but it's not easy because Helicobacter pylori is fastidious. Or the easiest way is to detect the enzyme urease in this biopsy. This is the most useful method to detect Helicobacter pylori. This is very fast, in less than 1 hour. So this is the diagnosis of Helicobacter pylori infection using invasive procedures through endoscopy, taking a biopsy. However, this is not the most common procedure. The most common is using non-invasive ways. The most common is maybe the urea breath testing. What is this? Maybe some of you have been tested by the urea breath testing. What is this? I will try to explain in the whiteboard. So, what is the urea breath testing? What is this? This is a breath testing. So we give urea to the patient to drink. So they drink urea. Well, they drink urea with water and orange juice to make it more tasteful. Okay, so this is what we give. We give urea to the patient. But this urea that we give to the patient is not, I don't know how to say. This urea is not normal. This is labeled urea. Radioactive. Remember this. This is the molecule of urea. We give urea using a special urea that contains radioactive carbon. Carbon 14, carbon 13. Radioactive carbon. This carbon is radioactive. So when this patient drinks urea, if the patient is infected, that means that the patient has a Helicobacter pylori in the stomach. So if the patient is infected, they have urease. In the stomach. So if the patient is infected, the urease enzyme is going to release carbon dioxide. Remember the chemical reaction. But this carbon dioxide is radioactive because this carbon is radioactive. We can measure this radioactive carbon. This is the urea breath test. It is very easy to do, and we do it many times. I did it myself when I was a medical student, and this is the most common. So this is the urea breath test for diagnosis. Currently, in the last years, we can also detect some antigens of Helicobacter pylori in stool. This is new, but maybe this is more expensive. This is what we are doing in the last years. So we have two methods in the microbiology lab to detect Helicobacter pylori. Okay, so we don't want to say anything else about Helicobacter pylori. Remember, this is the most important, the most common chronic bacterial disease in humans. The last fastidious organism that we are going to study is Legionella. But before we continue, I am going to delete this. So I have a space to write. But about Legionella, we are going to say very few words because we don't have time. Legionella is the last one. The most important species that we are going to study is Legionella pneumophila. Legionella pneumophila is a respiratory pathogen. It's a respiratory pathogen, but the transmission of this respiratory pathogen is not through droplets. It's not by droplets. Not droplets. This pathogen, Legionella pneumophila, is not spread from person to person. The transmission of Legionella pneumophila is from the environment, through the air. This is called airborne transmission. Airborne transmission. This is totally different to droplets. Remember, the transmission through droplets is possible in a very short distance, around 1 meter, 2 meters. So very, very short. For example, the coronavirus, very short distance. However, the transmission through the air, so airborne transmission, is possible in a very long distance, sometimes hundreds of meters. Why is this possible? Because these particles are very small. Remember, the size of droplets is very large. It's more, well, very large. Not very large, but more than 0.5 micrometers. However, the transmission through the air, airborne transmission, these particles are smaller. These particles are, the size of these particles is less than 0.5 micrometers. Because they are very small, they can travel a very long distance with the air, hundreds of meters. So they are more dangerous because the transmission is possible in a very long distance. Okay. Legionella pneumophila lives in the environment, usually in humid places, in places with water. For example, in nature, Legionella pneumophila lives in the lakes. And in pipes of buildings, for example, in pipes that contain water, of course.